Hello people, welcome to the show. My name is Irrelevant and this is Do All the Things, and on today's episode, the moment you've all been waiting for. For today, I finally start a SLO Clone build. That's right, I was commissioned to build a SLO clone. If you've been following the comedy, you might recall me making references to this project, preparing for it, salvaging transformers from other projects, and so on and so on. If you're just tuning in for the first time, well, you're in for some good information because there's things wrong with this kit. Things that need to be addressed, things that need to be adjusted, things that need to be pointed out if you're going to make the best version of this. So this kit was purchased from a guy on Kijiji. A good guy, pretty much knows what he's talking about when it comes to amps, though he did admit this is his first foray into high gain builds. This is not my first rodeo in high gain builds. The first clone I ever built was a Mesa Dual Rec. Of course it was imperfect, but it worked. So there's a few things going on here that are not indicative to a high gain build. The first thing that stands out like a sore thumb is the grounding scheme. Now, if we look at the chassis, we have a chassis mounted input jack, which has been removed, and chassis mounted effects loop jacks. And this guy, it comes with documentation. If we look at the documentation, okay, well, those effects loop jacks are gonna hard mount to the chassis. They're gonna get grounded there. Oh, they're getting grounded via these shielded cable. And then these shielded cables are getting grounded to the buses on the board here. You pick one, bud, not both. Same thing with the input jack. Well, kind of not really. It's got a ground wire going to the PCB bus, but it's also grounded to the chassis. We also have a chassis ground here on the ground star, which appears to be drawn over one of the mounting points for the power supply board, implying that this is going to be a chassis mounting point. So we're gonna have a ground loop from here through the board to here, all the way back through the chassis, which is not how we do things anymore. In the vintage amps, they did it that way, but I don't believe the SLO is based on that system. Now, some of what's suggested by these documentations that this is kind of a community project, SLO Clone forums. So, you know, this is a think tank, if you will, that put this together, and maybe someone had a real SLO and they just reverse engineer and looked at the way he did it. There is another technician I was talking to locally. He's repaired thousands of amps. He says, SLO clones are noisy. Yeah, I'd believe it. Looking at this, it's no good. So for starters, that input and those effects loops are getting replaced with the isolated jacks, the plastic types that will not ground to the chassis, and then we can independently ground them to the circuit proper, because you ground to the chassis at one point and one point only. At the ground star here is just fine, provided your grounding is done right everywhere else. Now the foot switch is still grounded, but you know, if we look over a schematic, that's fine because it's on an independent circuit. I've looked over the board and at no point else on this board is the foot switch circuit tied to ground. It's only done here, which isn't a bad idea because technically it's better for safety that your foot switch is at the same voltage potential as ground and not floating. And it's on an independent power supply. And that's one of the reasons why the foot switch circuit is on an independent power supply coil, because if it was on the main coil and you grounded the circuit this way, you would end up short circuiting across the artificial center tap or this whatever center tap. So there are ways to run the foot switch off the standard filament supply. It would simply mean lifting the ground here, again, using a isolated jack. Use one of these jacks and you could run it off the normal filament supply. Other amp manufacturers do that. It appears Marshall does that, at least the schematic for the Jubilee suggests that it does. And at 6 volts, you're not exactly burning down the house or getting zapped if you spill beer on your pedal, so another thing that stands out like a sore thumb for grounding is we have the mains ground going to this ground star. That's wrong. It works technically, but it's not to electrical code. A modern electrical code dictates that this mains wire has its own independent lug bolted directly to the chassis in such a way that it cannot come loose, and it shares a ground point with nothing else in the circuit. That's an easy fix. We'll have to drill another hole somewhere here and mount a bolt to strap that down, but it'll be fine. Now, apparently these parts were acquired from a Russian. There's an eBay seller who sells these clone parts. This is one of those Russian-made chassis. I wonder who provided the documentation. Trontonian or the Russian? I don't know. A couple other things that stand out. There were corrections made to the SLO circuit. Namely, if we look at the schematic, it's in the effects loop. Right over here, we got this thing going on where it used to be a 2.2K resistor, and then it was updated to a 1K because it was sending too hot of a signal to certain effects pedals. And then also part of that mod is over here on the FX recovery, a bypass capacitor was put into place that virtually boosts up the gain of this recovery stage just the right way to compensate for the drop of signal over here. Now, this is reflected in the schematic they gave us. Right here, there's the original 2.2K, and then they're like, okay, but here's a note, install blah blah to release the del level. Oh, to 0 dB. I guess it was a +4 before. They show the 1K, they show adding this bypass cap. So it seems that they have specs here to go either way. Now, on the layout diagram, it appears to show the 2.2K and not the bypass cap that would go here and here respectively. However, I haven't yet checked all the bags of components to see what they've given us, because I've noticed in some of what I've seen so far, some of the components we received are not correct because this layout diagram and this schematic differ. A perfect example of that is the depth mod is on the schematic right here, but it's not on the layout anywhere. In fact, the layout is for the original and the schematic is for the Mark II. People buying this kit not knowing the intimacies of amp design or the SLO might overlook that. And in fact, it does cause a bit of conflict because if we look at the power supply diagram, it shows the additional LDR5 that is in the Mark II. And then there's an asterisk here by R64, number 13, which is a 47 ohm. And it says right here, reduce R64 to 33 ohm if adding LDR5. I have already tested out the switching circuit on the board and they gave us the 47 ohm resistor as per the Mark I schematic. But this is a Mark II board with 5 LDRs. You see, got a wrong component. And if you're just going by the layout, you'd be like, oh, put that there, not knowing it's not gonna be working right. Now, unfortunately, I do not have a 33 ohm in stock, but I have hacks. I do have a 120 ohm. And if I add that to the 470, that's gonna come up with 33, according to my math. Another note here while we're on the power supply page is running this thing here, 6.3 volts. Note number 14 right there. It says reduce R61 to 5 ohms or remove it if using a 5-volt tap. That's exactly what we're gonna be doing. Chances are, if you buy yourself a nice transformer for this build, it's not gonna have two 6-volt taps. It's gonna have a 5-volt tap on it for a tube rectifier, which you're not gonna use in this. It doesn't have the right kind of power supply for it. Don't try it. Now, that's one of the reasons why I mocked up the switching circuit on here to run some tests, because actually before I noticed that note there, I reverse engineered the switching circuit to figure out what resistor I would need to compensate for that. And my math actually came up with 6 ohms. So that's what I'm going on there. 5's close enough. I wouldn't hesitate to throw a 5 on there. Other strange things is our effects loop routing. We have the finger going to the finger on the other side. That's not typically how you do the effects loop. The finger disables the return, but the send is usually hard mounted to the tip so that you can plug, you know, an output feeding something else, but still have your amp work. That's fine though, because chances are you're not gonna run it that way. There's no clear labeling on what does what in the switching. On our chassis, we have our bright normal, our normal overdrive, and our crunch. And on normal overdrive, they have this switch, whereas they have these switches on the other. That's wrong. The guy who pre-fitted this chassis, I didn't put it, the kit came like this. He's got the switches in the wrong position. Because you see this DP-DT switch would be for this function right here, SW1, which is unlabeled. What is that? That is actually the clean crunch functionality right there. This little network here kind of changes the gain structure of the normal channel. SW2, that's your bright switch. So bam, that's fine. And then this additional switch here, the normal one, that's gonna be your normal and overdrive switch because that's essentially channel switching, which isn't reflected on the schematic or the layout anywhere. Basically, that switch is just gonna hook up to your foot switch here to trigger your switching matrix. But none of these layouts address that. Oh. Well, the layout does kind of suggest to you what switch does what here, so that's cool. You honestly won't get that confused. I'm sure anyone who's capable of putting this kit together would notice that situation. Something else that stands out to me when it comes to the grounding scheme is the use of shielded cabling, which is not a bad thing, obviously. You got shields going all the way because we're crossing the board here. And then what's funny is over here with this switching here. So we have our input, goes here. Oh yeah, shielded input, that's common. And then we have a shield going from the normal gain to here. Now that's going from the gain knob to the tube. A very small jump going from here to here. But as you can see, all this switching network is part of the normal channel here. That switching network is here, but this cable is unshielded. Why would you go through the effort of shielding this little connection, but not all this? I guess having this resistor network here will suppress interference, so maybe it's not that important, but that's just something to keep an eye on. But same with the OD here. You've got a shield going from here to here, but they didn't bother to shield the supply going to it. Again, you might have some suppression here because it's going through a resistor, but still, these two green wires here, I'm gonna shield them for good measure. I'm sure there's other things that I've noticed, but those are the major ones that I wanted to bring to your attention right off the bat so that you know to look out for those if you're building one of these. Now let's get on to component selection. We got a free Tupperware tub with it. Supposedly all the components we need are in here except for the ones that I added. There's the 6 ohm resistor and then, oh, these guys. Now the guy who sold us this kit, you know, he's done Fenders and JTM 45s, but something he didn't quite realize is that when you're doing a high gain build, you can't run raw sockets. He gave us raw sockets with no tube shields. This thing's on here just to mock it up to see if I could fit a tube shield. Indeed you can. These are built-in sockets. There are built-in additional tube shields you can get. You need at least 1 tube shield for this kind of high gain build on V1. At least. We have purchased 2 for V1 and V2. The rest are going to sit in a gain range where you can get away without them, so we'll see. We got standard chicken head knobs, much to the dismay of the client, but apparently it's impossible to find SLO type knobs. Here we're adding a 50K potentiometer to the dealie for the bias. Now this amp does have provisions for an adjustable bias. This schematic's calling for a 25K. The documentation I have calls for a 50K. The part that was provided, I believe, are 50Ks. But here's the thing, they have our bias test points here, banana jacks, that's cool. And then an adjust, but there's nothing really, the pot would just get mounted on the board. There's a little pip for it right here. So what did they intend you to do here? Now I can, or you can, if you add a couple standoffs, pop a couple holes there, you can easily mount a little hobby board on there like that, put the little potentiometer on there, and then you would have, you know, a little a hole you could poke a screwdriver into to adjust it. We're actually going to be adding a proper 50K potentiometer. We're gonna put it in one of the empty tube sockets. We're actually doing a 50 watt build here, not the 100 watt build. So it came with the components for a 100 watt build, but we're gonna be removing the tube sockets. I'm just gonna put filler plates in. I'm gonna try to figure out a way to rig up a pot in the empty slot. Talking about 50 watt builds, transformers, always subject to controversy. In a previous video, I did a bit of a transformer shootout. I was able to determine that if you are looking to build an SLO, the Hammond 1750D is an excellent option. So far, I've been liking it in my Jet City, and it has roughly the correct numbers. For 100 watts, it's 2350. Now, it's a bit small for a 100 watt transformer that would typically be in a high gain build like this, but it's the right size for a 50 watt, and all you have to do is jump down the taps, right? Plug your 16 into the 8 ohm, plug your 8 ohm cab into the 4 ohm, you lose 4 ohm, and your 16 becomes a 32, which is not practical, but you still end up with 8 and 16, and that's mostly all you're gonna need. Once you do that, you get your 4.4K you need for a 50 watt build, because even though it says 2350, I tested my sample to 22. So they're pretty much dead nuts on what you would need for a Soldano build on the cheap. Just I do believe in a 100 watt configuration, it would probably break up and saturate a little early. Not sure. Now this guy doesn't have to worry about that because Well, we found a cheap broken Jet City and we've pulled the transformers out of it. A JCA 50H 50 watt output transformer, and it's sizable. Like, that's a larger 50 watt transformer than some amps. Now, mind you, I also found that the Marshall transformers that Hammonds make, the 1750N, would work well, and probably their 1750U for 100 watt, even though their impedances are a bit low, so your tubes are gonna run a little wild. Now, if you're unfamiliar with the Jet City, it's pretty much a Soldano clone, pretty much. The schematic is very, very close. So much so that people buy them and then just adjust some components to turn them into a Soldano. It's a great sounding amp so far, and it's designed by Soldano to Soldano spec, so these are Soldano spec transformers. That's the philosophy behind this choice. We have a proper output transformer to try to get something closely resembling a Soldano tone. And of course, out of the deal, he gets the 10H choke that also came in the JCA, which we're probably gonna mount externally. For the power transformer, we got this mushroom looking buddy right here. That's a Hammond 273BZ. Now, they don't make this current one. This was a used, maybe NOS. It looks in great condition. The leads are cut a bit short, so it's definitely been used. They don't make this guy anymore, but in their 200 series, they do make the 273BX. So 273B, 273B. Z is the form factor of it, whereas an X is a standard stand-up transformer, and that's more closely what you would want to get. Now, why the 273B? Well, let's look at the spec sheet. In the Soldano, 4 power supply transformer, 450 watts, they're calling for 360, 50, 360, 200 milliamps. So 360 by 360, that's going to be 720 volts center tapped with 6 amp heaters and a 2 amp switch. What's our Hammond got? Our Hammond is 700 center tapped. That's 350. That's a difference of 10 volts a leg. So our amp's going to run 10 volts less than spec. But you know what? I will say with confidence, you're not going to tell a difference in 10 volts. Your amp is going to sound and function identically, but it's 201 milliamps. So boom, we've nailed our B+ requirements. Our 6.3 volt is center tapped, which is good. I like that better than the artificial center tap, and it's 5 amps. Ooh, that's 1 amp less. Well, let's look here. The biggest heatered tubes you could possibly put in a 50 watt build, it's gonna be like 1.6 amps a tube at the most. That's 3.2 amps of heater current draw. And then we have 5 12AX7s at 300 milliamps each. That's 1.5 amps. 3.2 plus 1.5 is 4.7. So we have our 5 amps, we have 4.7 amps of current draw, 6 amps, bit overcompensating. Maybe there's a reason for it, but we're gonna be fine. And then we have a 5 volt tap for 3 amps, so that's gonna run our switching. Those LDRs, they fire at like 2 volts at the most. There's no reason why you can't run the switching matrix off a 5 volt supply. It even says in the specifications, we're just gonna lower the value of 1 resistor to compensate. So if you're looking to do a 50 watt Soldano build, the 273BX is pretty much dead nuts what you need. However, for 100 watt, it becomes up to philosophical debate. They're asking for a 400 milliamp with 9 amps of heater. Based on my calculations, a 100 watt amp could pull up to 7.9 amps of heater. So yeah, you need at least 8 amps of heater. 400 milliamps seems odd. That math is kind of funny to me. Again, we're overcompensating. I don't even think you need 200 mil. Well, yeah, it's a high headroom amp, eh? Does Hammond have anything that fills that bill? 600 at 287, but that's getting a bit low voltage. That'd be 400 volts B+. That's too low. That's too low, bud. Yeah, Hammond's kinda Now this was gonna be mostly a talking head video. What I am going to do today, while we're still filming, is I need to fit these transformers. Now this guy goes somewhere over here, and we got lucky that 2 of the holes in the front line up. The guy who sold us this kit, he already piloted and drilled the transformer holes for some Italian-made boutique transformers. That's not what we're using. So the holes line up front here. We're gonna have to add new holes into the back. And of course, we gotta punch a hole in center to get our wires through. How to do that, we need to tuck these buds away so that we can seat this thing down. I'm gonna have to extend all these leads because they were cut too short. I'm sure they worked great for the last guy, but they ain't working for us, bud. That should be good like that. So we got 2 new pilots right here for 2 new holes. Let's get the consultant in here real quick. Even though you shouldn't call a consultant till you're ready because they charge by the hour, right? Buddy's gonna watch this video and cringe because he paid a lot of money for this kit and I'm banging it with a hammer. Oh, the output transformer goes somewhere over here. Got holes that line up if we mount it like that, but that doesn't seem right. Oh, we got holes that line up if we go like that too. Where do we want to bias it? A little bit more this way or a little bit more this way? Probably a little bit more this way so we know it clears. We need a new hole here and we need a new hole right about here. And unfortunately, we're gonna need a new hole to mount a grommet in here. So that's that now. Let's make best use of our consultation. Now, the choke. Like the Jet City, we're going to be going with an externally mounted choke. So this guy is going to hang out right here. The wires will come around back where there's already a grommet waiting. So we're going to need an additional hole somewhere around there. And I'm hoping, yes, that will roughly line up with the hobby board. Another thing that I'm doing with this amp that's not in the schematic and is actually in new SLOs is I'm going to be using DC filament heaters. You see, that's another thing with high gain amps. That V1, at the very least, should be on a DC filament. So we have to add another circuit board in here. And the plan was I was gonna put it right here where the choke would normally go. This is the perfect spot for it. It won't get in anyone's way. There's not really a super convenient place to locate it anywhere else. I don't want to put it too close to here because the switching noise of the rectifier's doing its thing might get into the V1. And we got a big board here and a big board here. So right there is about perfect. Wait, that's sharing. Okay, hold on. The choke holes are here. Transformer goes here. Do you want to choke out in the open there? That's a bit of aggressive. Like over there is where it belongs. So not a good spot for it if we add 50 watts. 100 watts, it's a bit close. We just have cheap plastic on here. I don't know if I'd want it there either. I think I would personally put it here, but then I like the industrial look, so having this out front is not a big deal to me. I'm gonna have to take some photos and email them. But either way, yeah. Oh, kinda have to start drilling now, sir. Oh boy. I'm gonna use the good bits for this one. So, how mild is this steel? Not too bad. Sure, we clean as we go. Those chips are gonna scratch paint. I sucked in my marker. Now, for the wire hole, which is gonna come up underneath of the power supply board. It's gonna make things tricky. Just gotta get a hole in the middle of this. Need to make that hole larger. Large enough till we can get this tool through. Because I'm not going to be using this butcher job here. I'm gonna be using something called a chassis punch. These are great tools if you're into tube building. I'll just put that through there. Put that on the top here. Screw this thing in the bottom. Then we do one of these. It's a little bit of hard labor. It's coming. Oh boy. Oh. Gonna need a cheater bar. Or something a little bit bigger. There we go. Also need a bit of oil. It's getting a bit tight on the bearing surface there, sir. Eventually, pop and we're through. This crappy slug here. And then this guy is needs some coaxing to remove. But chassis punches are great because that is a clean hole. I got this plastic ring salvaged out of an old power supply. And then that is going to be perfect for the transformer, I do believe. Assuming I can get the 25mm ring in the 25mm hole. Might need some fitting. Oh no, there it goes. Oh yeah, that's big now. And low profile enough, it should all fit. Before I get too into things, a great place to salvage a ground lug is also off old power supplies. You'd be surprised how many components I salvage out of old power supplies. They're an excellent source of MOSFETs and capacitors. And this is exactly what you need right here for your chassis ground. We can even salvage this stud out of here. I'm gonna see if the consultant can offer some advice on this one. Oh, this thing's dusty. Well, it's interesting how that works. There's no anything on the other side, but I think that's gonna fit our application nicely, assuming I can get it tight. We're gonna find out. So we got that ground lug. We got some potentially nice pieces of mains wire that we can use for this. Like, not that I don't have wires that I can use to do the mains, but heck, if we can repurpose some perfectly good pieces of wire, hey, that's awesome. The important part is that we get this ground. There we go. That's a nice, good spec ground lug right there. I do believe I have drilled all the holes that I need to drill, so I'm gonna put this away and reorganize the space. Now we need to make sure our workspace is reasonably clean. It's a nerve-wracking process putting all those holes in there because, you know, at any moment you could scratch the paint job on the chassis. This is a new piece that a lot of money's been paid for. Now it did have blemishes to begin with and you got a bit of a deal for it, especially since Buddy started popping holes into it. So I could start mounting the bulk components. And part of that entails making sure that everything that is mounted already is tight, like this IAC. Because no, indeed, a lot of this stuff is loose. He just loosely threw it all on. You need to do the finished fitting. Now, while I have the soldering iron heated up, I'm going to do one little bit of soldering here, because I'm not actually planning on getting any soldering done today. But we have this ground lug, and we have an extra hole here because I had to move the holes for the transformer. We're gonna be using these holes, and that is a spare hole there. Now, where we are going to have ground points, we need to prep that surface for good conductivity, which is easily done. A little wire brush on our spin tool. Working with these little wire brushes is a process I'm particularly fond of because they have a tendency to throw little pieces of metal hair all over the place that you pick up later in the form of slivers. I already caught one, especially in your foot and socks. I remember now, one of the tricks I used is to have the vacuum running. It intends us to star ground on this lug here. So we gotta prep that surface too. I think he used aluminum standoffs. You gotta be careful with mixed metals and electricity. Actually, yeah, we're not gonna put that back into place. I think I have, yes, standoffs the same length, almost. I'm gonna replace it with a steel standoff because as soon as you start exposing metals to electricity, there could be strange forms of corrosion that happen. All right, one more little jaunt with the spin tool. I still felt crap fling around, but significantly less. The rest of them I'll leave aluminum. That polished surface now will allow us to get good conductivity to the chassis. Robertson red. No, this is green, bud. What are you talking about? Go through, make sure all these standoffs are tight. Indeed they are not. Careful if you're using aluminum components, right? You know it's easy to strip that out. This one doesn't match. Or no, that's for a reason, because it's underneath the transformer. Okay, well, that's some thoughtfulness. All right, all the PC board standoffs are on there strong. Oh, there's crap everywhere. So now that I've done polish that, I'm gonna try to get this ground lug into place. All right, that looks good. Now where's our hardware that we had? This thing looked like it was going to be the right size. Stick it through there. It's got like these locking serrations. Oh yeah, it's working nice. Yeah, see, that is a proper ground point. A little bit of dirt around it, but it's not going anywhere. And that special bit of hardware, it bites into the other side and it's low profile. Look at that, that's nice. Salvaged from an old power supply. You don't necessarily need to have virgin components for everything. Now the next thing I want to do is mount those transformers. It might seem premature, but there is a method to my madness. I've been to the local tire store and acquired the necessary hardware to do this. It's M5 metric, but that's because they had the slightly shorter bolt that I needed. Washers have a sharp side and a smooth side. I tend to put the sharp side up so it's not scraping up whatever I bolt it to. Now we just have the nylon lock nuts, eh? Let's get us an 8mm wrench. I also like using fender washers in this inside here for extra support. All right, this guy should torque right up now. All right, first transformer's mounted. Let's get the second one on, because these things are gonna give me clearance, right? It's gonna allow me to be able to work on the chassis while having it sit. There we have it. A pair of mounted transformers. This will give us some support, a bridge by which to continue our work. Just want to do one thing before I get started. That is, because we're gonna be sliding these around, put some protective tape over top so we don't scratch them up. I ultimately mounted the bolts upside down because it would be very difficult to get them the other way. These switches are a bit loose too, and the way these work is interesting. We need to figure out what position's on. Sometimes on is the same side as the switch, sometimes it's the opposing side. Continuity in the multimeter says it's the opposing side. So, lugs here, on is this position. We want that face up. Want to run this nut back. till we have just a peep out there, like that. Then it's a question of getting the correct size wrench in there to tighten them up. What size wrench are we dealing with here? 14.37, 15 mil? It actually appears it might be Imperial, but 15 mil should do. So if we can get in there, ease her up. Yeah, it's working. Same as the first. Now mind you, we probably should have mounted the pilot light first because that's gonna be a bit harder to get a wrench in there. We're good. Tight. I gotta pull all these pots out to make sure the right values are in the right order. Because like these switches over here aren't correct. The washers on them aren't even correct. They put the outside washer on the inside. A500. Why are those preamp knobs the only ones with lock washers? A500, don't assume they're all put on correctly. Oh, that stupid washer's all warpy. Is that shaft even on straight? What are you doing, bud? SLO V. A1 meg and bass. Yes. Mid. B25. Yeah. B250. Treble. A1 meg. Normal. Yeah. Those are both going to be 1 megs. Presets. B25. Yep. And, you know, by process of elimination, what are the chances that this one isn't what it's supposed to be? A1 meg is indeed what the depth is supposed to be. So normal bright is one of these normal little switches. Doesn't really matter what way it goes in. Now, let's see if I can't tighten them from the inside. What size are these? 8 mil? Didn't I grab an 8 mil wrench already? There should be one on the deck here. Come on now. There you are. Yes, it's 8 mil. Yes, it fits. Or does it? All right, that switch is in the way it should be. Clean crunch. Put channel in next. Having the transformers in place also gives it an anchor. You can put it into different positions without it like friggin' off on you. Where's our jack? It's very much in specific. Isolated jack's gotta go in here now. And the hole's not big enough, so that's awesome. How far off are we? Jack needs a hole of about 10.811 mils, and this hole is about 9.67. Damn. I was really hoping I was done drilling today. Gotta go up to 7/16. Fits now though. That means I also have to do the same thing to the effects loop, because those are also getting replaced with isolated jacks. Oh yeah, it's much nicer working on this with the transformers mounted. Ho, let's give it a try now. Well, we know it's gonna fit now. Oh, should I put that black ring on the outside like that? That kind of works, doesn't it? Even though it's not supposed to be like that. It's supposed to be on the inside. The effects loop, yeah, even though I might need to move these back out to get the wires on. Yeah, they'll probably need to be readjusted after. Oh boy, that bolt is like right close. It's gonna clear, but that almost seems like I didn't think about that. Everything on the front's tight now. It's these back parts, like this switch, whom part number I want to find out so I can order some just like it. Nekai Japan HS13 NNK. Oh, look at those nice high current connections. So common appears to be this guy. And look how lucky we got with these wires. We pulled these transformers out of a different amp, and this is all the speaker lead we get. But look how we lucked out, because they're just going to reach the switch. With the exception of the ground wire here. We're gonna have to get creative with that. Chances are I'm gonna have to fine tune this, but the purple will reach, and that's the shortest one. So these jacks, I'll tighten them down once I got wires on them. These things, they can get tight now. These are just plastic, so you have to be real careful with the torque on them. I noticed that these tube sockets, big octals, are mounted counter to the layout. Sure enough, these guys are upside down too, according to the layout anyway. Yup. Gotta redo everything. Which transformer's heavier? Hold this guy up. Neither. Tube, shields, going in. They fit nicely. They're belted shields for belted sockets, so they fit nicely over these belted sockets. Ah, all the sockets are mounted. And perpetuating the cycle of violence, I took a tin snip to this old power supply enclosure because it had this nice matte black finish. And with that material, I fabricated these hole fillers to go into the tube sockets that aren't getting used. This one needed some shaping. These guys, nothing fancy on these guys. Now, there were nuts and bolts that came out of that hole, but for these guys, I was just planning on using pop rivets. I use pop rivets in my own amps. They work. Just want to make sure you hold it real straight when you're putting it on. It's easy to get a rivet in wonky. Now the rivets are aluminum, so it's easy to drill that out after if you've made a mistake. But you're gonna notice this one has a hole in it. Well, that's because this is where the bias pot's gonna go. Something like that. Or maybe something more like that. Or like that. I don't know. Doesn't really matter. There's one last thing. The choke will have leads come through this one spare grommet. And then it goes into these holes here using spare hardware left over from the tube sockets. And maybe some washers. Didn't I get some washers for that? Yeah, all sorts, bud. Double check orientation. Well, it's about as good as it's gonna get. The way he did standoffs makes more sense the way that I'm doing standoffs. Because I gotta mount 2 standoffs. One right here and one right here now. 632. Just test fitting this. Survey says that PCB fits. And that will be our DC board. So what do we have here, bud? All our internal connections are tight now. Oh, our fuse holders. Fuse holders need a snuggin. Will any of our mains wires reach? Oh boy, look at that. It'll just reach. That's not what it's supposed to reach to though. It's supposed to reach down here. But you know, if we go ahead and will it reach to the switch? No, it won't. Yeah, and you have to go to the fuse first, then the switch. So these leads are gonna have to be extended just to get there. But everything's mounted. Tube sockets are mounted, transformers are mounted, tube shields are mounted, and our extra holes are filled. Look how nice that looks. That was a good solution. That looks better than what I expected. Yes, we have an external mounted choke. He doesn't mind. Neither do I. I like it. I'll probably use this hole here to get like a wire clamp. I got something like that in here. And then that'll just hold that down there. And then yeah, next step, I need to start putting the PCBs together for it, the circuit boards. But that's for another day. This was my quota for today, and now it's done. So I hope you enjoyed this. Stay tuned for the rest of this build. I'm hoping this was a 1-part. Probably have 3 hours of footage again today. I have to cut down to 30 minutes. Oh boy. Yeah, well, that's how it goes.